Okay guys, so the second half of the exponential functions unit, we learned about transformations, and there were two more parent functions that we took a look at here, and we talked about three key features of exponential functions. So we talked about the 0 point, the 1 point, and where the horizontal asymptote occurs. Now we can assume for just base parent functions like y equals 2 to the exponent x, that our horizontal asymptote is always along the x-axis at y equals 0. And to find the 0 and the 1 point, we're just going to plug them both right into this equation here. Okay, so 2 to the exponent 0 gives us 1, and 2 to the exponent 1 gives us 2. Okay, these are our three key pieces of information for this parent function. Okay, we're going to do the same thing for our second parent function here, find the 0 point and the 1 point, and again, we assume that our horizontal asymptote is on the x-axis. Okay, so I'm plugging in 0, 1/2 to the exponent 0 is 1, and 1/2 to the exponent 1 is itself, which is 1/2. Okay, these are our second set of three key pieces of information for our second parent function. Okay, what we end up getting are basically two opposite functions. So one of them is growth, and one of them is decay. So 0, 1, and 1, 2 ends up giving us this curve right here. And for our second one, we still have that y equals 0 asymptote. Remember, our asymptote is where our function cannot touch or cannot cross. It's undefined here. So I'm going to have that y equals 0 there, and then I'm going to plot the points 0, 1, and 1, 1/2. So we end up getting almost like a flipped version of this graph. So these two are essentially just almost like horizontally flipped. Okay, again, this guy, the 2 to the exponent x, that's almost like our b value. So we know b value of 2 is doubling, so this one is representing exponential growth, and this one is representing exponential decay. Okay, let's take a look at a transformation of one of these two functions. Okay, so before we go to an actual example, it's important to know where you're going to see transformations in these equations. You're going to see the a outside, as you normally do, and the c outside, as you normally do. Those are, again, changes to the y coordinates. And here's our k and our d, and we're going to make sure that the k is common factored out. Okay, that's important, or else we won't see the correct shift. Okay, and you're going to notice this b value right here. The b value is not a transformation. It represents whatever our parent function is. So our parent function will be b to the exponent x, whatever that is. So if we see a 2 down there, for instance, that will be like 2 to the exponent x. Okay, so it's important to remember that that base of the exponent is not actually a transformation. Okay, so I've written an example here just so we can kind of see. Here are a and c values on the outsides, and our k value and our d value we can see are up in the exponent with the x. Okay, so k and d will always be kind of like attached to your x value. And this is actually telling us, this base right here is telling us that our parent function for this equation is y equals 2 to the exponent x. Okay, so I'm going to use the three key pieces of information that we just talked about on the last slide in order to do transformations here. Now, there's one other problem with this equation, and that is that we do not have the k value common factored out. So I need to take this 1/4 and actually common factor it out. And when I take 1 and I divide it by 1/4, what we actually do is we multiply by the reciprocal of the 1/4. We end up getting 4. You can try on your calculator if you want to double check. Okay, or you can even just FOIL this back in and double check. So we get 1/4 x, and then we get 4 times 1/4, which is 4/4, which gives us 1. Okay, so that makes sense. All right, so now we can see our actual equation here. We're going to do the transformations. Okay, so I've gotten ready here with my parent function key points, three key pieces of information. My horizontal asymptote is going to move up and down with whatever the c value is. Okay, so in this case, my c value is -3, so my horizontal asymptote is going to move down 3 units. Okay, so here we go. I'm going to use the same kind of idea as before with the 1/k x plus d and the ay plus c, if you watch the transformations video. So reciprocal of k, the k value is 1/4, so the reciprocal of that is 4 times x, and that was this value here, and this is the d value. So we're going to swap the sign of the d value, we'll get -4. Okay, so for ay plus c, that's the 2 and the -3 here. So we'll do 2 times y, subtract 3. And we'll take a second and just calculate our x values. So we'll get -4 and 0, and calculate our y values. -1 and +1. And then, like I said, our horizontal asymptote is going to move with the c value. So it's going to be at -3. Okay, on the next slide, we're going to graph these things. Okay, so I'm going to start by drawing my horizontal asymptote for my parent function. We know that that is along the line y equals 0, which is just the x-axis. Okay, y equals 0. And then I'm going to graph my two parent function points. So 0, 1, and 1, 2. Okay, and we already kind of did a little sketch of this one on the first graph, so we know this is the parent function 2 to the exponent x. Okay, I'm going to graph the second one in red. So the first thing that I'm going to do is I'm going to draw the horizontal asymptote along the line y equals -3. Okay, this just kind of helps me figure out where my function is going to avoid. Okay, and then I'm going to graph the points 4, -1, and 0, 1. Or -4, -1, and 0, 1. Okay, so -4, -1, and 0, 1. Okay, so here is my function. It has to curve along the asymptote, and it's going to go up like this. Okay, so there you have it. There's our function, and I hope that this was helpful for you.